Good afternoon. I'm meteorologist Nathan Scott. Welcome to WeatherWise. Today, we're going to focus on what happens with weather and how the mountains affect weather. Let's take a look at the geography across the United States because it plays a huge role in what type of climate locations see across the country. Of course, we have the Appalachians stretching from primarily Alabama all the way up through Maine. It's oriented from the southwest to the northeast. Keep that in mind because that's going to play a crucial role in what type of weather conditions, say like northeast Tennessee, can experience at some times during the year. Then you have the Rockies. They extend from pretty much the north down to the south, from Montana all the way down through New Mexico. And of course, you have the Sierra Nevadas that go from California and all the way down into southern parts of California. In between the Great Basin, that includes Nevada, Utah, Idaho, and all this different type of geography can play a huge role in what, say, Los Angeles sees versus maybe what we see here in Arkansas. Let's go over to maps now because we're just taking a look at a graphic. This is a mountain, a realistic looking mountain, and you see what's happening here. The one side of the mountain, we've got clouds, we've got lots of vegetation, lots of trees. The other side of the mountain, more dry. The vegetation, a lot more sparse. And you learn this in 5th and 6th grade. It's known as the rain shadow effect. But there's more to it than just where it's going to be raining versus where it's going to be a dry climate. So here's the breakdown on the windward side of the mountain as the winds come from the direction, and we'll say coming from the right. The air has to go up and over the mountain. For that to happen, it has to cool and condense. So we see the air rising on that side of the mountain. And then on the opposite side, the air comes down the mountain and we see it sink. That's known as the leeward side, the other side of the mountain where the winds come up and over the mountain. But there's huge implications on the significance of how much air is going up and over the mountain, which would equate to how much air is coming down on the other side. So when we take a look at what happens weather-wise, this is known as orographic lifting. We see this a lot. So on the one side, the windward side of the mountain, you have that air rising. It forms clouds, it cools to the dew point, condenses into water vapor and eventually water droplets. I've seen this a lot, especially when I was in northeast Tennessee, where if there was an easterly wind coming from the Atlantic Ocean, that moisture from the Atlantic would bank up right along the eastern side of the Appalachians into North Carolina, and they would be cloudy all day long. Meanwhile, on the opposite side, if the winds were coming from the east going towards the west, you would have the sinking air in northeast Tennessee, and we would see lots of sunshine. When the conditions are right, of course, you can have snow on top of the mountain. And then the other side, there you see, as the wind descends down, sunshine and dry. And I've seen it many times where pretty much the temperature range is a huge difference on one side of the mountain versus the other side. This is just an example. We'll call it a tale of two sides because let's say the one side of the mountain, the windward side, that's seeing that rising air, it's 41 degrees around the valley area, but then as that air cools, condenses, you know what happens. We see usually snow on top of the mountain. That's because the temperatures are, of course, much colder the higher and higher that you go up. But if you've been on a mountain, you know how different things can change in a short amount of time. I have a cousin, he went hiking. It was out in Montana, and he left. In the morning, it was clear skies, but by the afternoon, the clouds bubbled up and storms developed. And he wasn't expecting that. Unfortunately, he was in a situation where he almost got struck by lightning, but thank goodness that he was safe and could get down the mountain before the lightning got really wild. But this is a problem for, say, prospectors, miners of aquamarine in Colorado, Mount Antero. Aquamarine is only found at 14,000 feet or above in elevation, and Mount Antero is certainly higher than 14,000 feet. and they have to be on lookout for changing weather conditions. And when you have rising air over a mountain during the summertime, you're not going to have snow necessarily. You could have a pretty nasty thunderstorm develop. Let's take a look at Storm Track 11 now, because another location that a lot of people are familiar with, Mount Washington. This is in New Hampshire, and I went there 2 summers ago. A great experience, but that mountain sticks out of nowhere. The rest of the mountains are much shorter, and there's no protection against the fierce winds of the upper parts of the atmosphere, or not upper parts, but once you get into 5,000, 6,000 feet, that's the mid-levels of the atmosphere. So you could have that low-level jet stream screaming across that region, and of course when you have no friction, those winds hit that mountain, and this is an observation that is taken for the afternoon. Current observation, there you see that it is one above at the top of the mountain at 6,288 feet. In the valley, it's 18.8 degrees, which the elevation is 1,600 feet. So the change is dramatic, and this can even happen in June. I went in June, and it was 60 degrees, sunshine in the valley, but you looked at the mountain, you could see a deck of clouds, and when we got up there, we went from 60 degrees into the upper 30s, and you cannot go in shorts and short sleeves when you head up to the mountain any time of year, because usually it's going to be much, much colder. But look at the winds that have been recorded. 60-mile-per-hour winds, a 10-minute gust of 75 miles per hour. The wind chill is 32 below zero, and that's what hikers forget about. They think, oh, it's okay, we're going from the valley to the summit and it shouldn't be that much of an issue. No, the conditions can change drastically, and you always want to be prepared for changing weather conditions, because one day it could be in the 70s, but a front moves through and down the numbers go, that wind picks up, and people have certainly lost their lives because they were unprepared when it came to experiencing mountain conditions that can change so fast. Back over to the graphic now, Perry. So here's just an example. I showed you 41 at the valley, 23 at the summit, but then on the other side, that air descends. It's known as adiabatic heating, and as the air descends, the temperature will be much, much warmer, 55. I've seen this happen too. Boone, North Carolina, on the eastern side of the Appalachians, could easily be 26 degrees, but then on the other side, especially if there's a southeast wind, Johnson City, Tennessee, or Kingsport, Tennessee, could be into the upper 50s. And covering that region was very challenging at times because of the situation with all the different types of microclimates that can happen due to the mountains. So when we talk about other effects with the mountains, downslope winds, compressional heating, adiabatic warming. Compressional heating is when, as the winds come down the mountain, it warms, and that's just because with a scientific principle of the ideal gas law, we see that warming happening as you go down the slope of the mountain. But also, you have to think about air is a fluid, and it operates like water. So if you think about, let's say this is a stream, and your mountain is a boulder. So if there's water going over a boulder, what happens? There's usually a rapid, and usually on the other side of the boulder there's like a wave. Air operates the same way. You have a wave of air, a huge rush of air pushing its way down the slope of the mountain, and you can experience something known as downsloping winds, or what's known as a mountain wave event, and it can be destructive. And I've got some examples of that, and you may have heard it before in some parts of the country. Also, enhance fire danger risk, because as these winds are going down the mountain, they're warming, but they're also becoming more dry, and that means lower humidity. One example, classic example, the Santa Ana winds. But you may have heard this before, the Chinook winds. Now, before we get to this, I want to show exactly where Spearfish, South Dakota is, because you may not be familiar with it. So we're going to zoom out, and here is Wyoming, right there, and then here is South Dakota, right here, and then Nebraska. If you've ever been in this part of the country, it's pretty flat. The Black Hills, I haven't been out in that direction, but Wyoming, it's very flat, and it's also very windy on the eastern side of Wyoming. But there's spearfish, so right there, and then looking off to the west, you'll start to run into the Rockies. And here's Yellowstone National Park, and here's the Grand Teton National Park right there with Jackson. So you have to think about 3D. We have winds coming from the west. They can go up and over the mountain, and then they come rushing down. There's something known as the Chinook. And this is a really interesting phenomenon because as those winds descend down the mountain, temperatures warm 5.5 degrees Fahrenheit every 1,000 feet. And this was experienced back in 1943, January 22nd. Just take a look at this. It was 4 below zero at 7:30. There was no wind coming from the west. There was no Chinook. But then the Chinook developed, and it made the temperature go up 45 degrees in 2 minutes. -4 to 45 degrees in 2 minutes. So you probably, back in the day, would have, hats, gloves, scarves, and then 45 degrees, you might have thought, oh, okay, this is feeling great. I can take this off. Well, then at 9 o'clock, it was up to 54. Turned out to be a really nice morning. But could people have been fooled by this? Because just 27 minutes later, the Chinook wind stopped, the compressional warming stopped, and the temperature plunged back down to 4 below zero. So that is a huge temperature difference within a short amount of time. Once again, it took place from 7:30 all the way until 9:27. That's the most significant example of a Chinook that's been recorded in the United States. But they do have a festival there in Spearfish, South Dakota, to pretty much respect the Chinook, because they do get Chinook winds, just maybe not this drastic, at least in recent history. Another thing that we talk about is the downsloping winds. Remember I told you how the air rushes over that obstacle over the mountain and then comes rushing down? Well, winds can roar down the mountain like a crashing wave. And when you have the wind perpendicular to a mountain range, so for instance, in Northeast Tennessee, our downsloping wind event would be if the winds were coming from the southeast, because the mountain range goes from the southwest to the northeast, it'd be perpendicular or make a right angle, 90-degree angle. When that happens, you would get tremendous amount of wind right at the base of the mountain on the other side, on the western side. So winds can easily exceed 75 miles per hour. One example is the foothills of the Denver metro. We just heard this a couple months ago. Boulder, Colorado, Aurora, Colorado, because you have those mountains, they're 13,000, 14,000 feet just outside the metro. And as those winds made their way up and over those mountains, they came crashing down like a wave and produced winds of easily 90 to 100 miles per hour in some cases. And that can certainly do some structural damage for those places that are not secure with this type of wind situation. Another place is Northeast Tennessee. And I tell you this as we go to Storm Track 11, because now we're looking at Northeast Tennessee, which used to be my home before I came here to Arkansas. I was in Jackson, Mississippi, and then before that I was in Northeast Tennessee. But here's the eastern Appalachians right along the border of Tennessee and North Carolina. And there's an area called Camp Creek. It's right about here. And that's because you see these mountains right here. They have elevations about 5,500 feet to almost over 6,000 feet. So as the winds come from the southeast, they come up and over the mountain, and you can easily get 70 mile per hour winds in this part of Greene County. This is a beautiful area of the country because you're sitting higher here in Greenville and you can look down on the valley of Camp Creek and these other little communities, but it can be sunny. And I went there when one of these events happened. Lots of sunshine, but the winds were howling, easily 50 to 60 miles per hour. And we were getting calls one day, because they go through this several times during the year, but we were getting calls that roofs were being blown off because the winds were going 90 to 100 miles per hour. Now, over this past season, this usually happens when it is the cooler months of the year, so November through March. So this is a graph of the past couple months. So there's December 8th, and what you want to look at is the blue. So if you follow the cursor here, they had a peak wind speed of 52 miles per hour during that event for that one, and then also they had a wind speed peak around also 50 miles per hour around January 22nd, I believe, or 25th. So they didn't have anything really crazy this year, but of course that can change because we still have March and April to go through. But yeah, this is crazy to experience, and if you are in a situation, you're hiking and these mountain waves develop, they can bring down trees and they can be very dangerous for hikers as well. So we have downsloping winds, we've got the compressional heating, the Chinook. You combine the two and you get something known as the Santa Ana winds. And the Santa Ana winds are notorious for people in California. They come from the northeast, and Santa Ana winds happens during the cooler months of the year. High pressure is over the Great Basin, over Nevada or Utah. Winds can bring in low humidity, easily go over 75 miles per hour, which can make for rapid and erratic fire behavior. Here is the diagram, I guess, on how everything comes together. So we are looking across California towards Nevada, towards Utah. Area of high pressure, airflow around a high pressure is clockwise, so the air is coming from the east and northeast. So there's the high pressure just to the east of the Sierras. The Sierras are easily 10 to 15, well, not say 15, 10 to 12, 13,000 feet. And they get a lot of snow, of course, when you have the winds coming from the Pacific Ocean. But in this case, we have the winds coming from the east and northeast, and therefore the winds have to go up and over the mountain range. So as that air makes its way up and over the Sierras, the air pushes down, it's compressed, it's warmed, and then on top of that, because the geography of California is so unique, you have a lot of places that are dry and deserts, which dries out the air even more. So as this compressed, warm air, very dry air snakes its way, meanders its way through the canyons into Southern California, that's when you have those winds really kick up, and any little flame, any little fire can get out of control very quickly. And of course, we saw that last year with a lot of destruction across a large part of the LA metro and those areas that are, susceptible to the Santa Ana winds, because as it goes through the canyons, there's just no stopping something when you have winds of 60 to 70 miles per hour. So meteorologists out there, that's what they really concentrate on, is going to be the Santa Ana winds. And they get a little more concerned, just like we get concerned about severe weather when we have something develop in the model forecast and we're seeing a weather pattern. When they see a weather pattern such as high pressure building over the Great Basin, over Nevada, over Utah, that's when their concerns go up for the potential of the Santa Ana winds, which really haven't been happening too much this year because they have experienced a lot of warm temperatures and haven't seen much of precipitation, which is not good because they need precipitation. There's a drought out there. Colorado has had some of the driest conditions so far this winter that they've been experiencing not much snowpack across the Central Rockies in the parts of Colorado. But hopefully the weather pattern is starting to change for those folks, and they'll see more of a dip in the jet stream, and will provide them with more chances of rain and snow as we go into the next few months. One other thing that's really cool about looking at mountain weather is I've never seen this personally, but this is something that just is, I think, really cool. It's known as a lenticular cloud. And this doesn't always form over mountains, but it does form the best chance over a mountain just because, well, I'll explain why in just one second, but it looks like a spaceship. And once again, I've never seen something like this, but it's called lenticular because it looks like a lens. You have that look to it over the mountaintop, and it looks like a spaceship. A lot of people would be like, what's going on? This looks really, really cool when it happens around sunrise or sunset. But the atmosphere has to be stable. And what you think about is as the air rises, it cools, condenses, and that forms the cloud. And then that continues to be the case until the other side of the mountain. The air sinks, so the condensation stops, evaporation happens, and that will end where that cloud edge starts to develop on the other side of the mountain. So this is also known as a standing wave because as the air flows over and continues to flow over, as long as nothing changes, this whole scenario will continue with the air rising and sinking over the mountaintop. And I have a really cool, I found this on treasuresjapan.com. This is Mount Fuji, but this is a time lapse. And I'm going to play this here. And you can see that cloud does not move at all. And there's actually two lenticular clouds. This is usually seen a lot of times over Mount Fuji. But as an airplane, you do not want to get anywhere near that because that can be a lot of turbulence. Because if you think about, that's a wave, and you don't want to hit that wave. You don't want to go through a lenticular cloud because you're going to be going up and then down. But that's just a really cool shot of lenticular cloud over Japan, Mount Fuji. As the other clouds are just moving along, the air continues to rise and sink in the same location. Now, you can get lenticular clouds also downstream from a mountain. And the reason behind that is because if you think about it, once again, as the air goes up and over this obstacle, it forms a rapid if it was water, but then you have other little rapids that develop. So you have this mountain, and then there could be another wave that could develop a lenticular cloud more in the distance, and then it continues to be that way until the wave starts to just wind down. So you can still have lenticular clouds. Even here in Arkansas, it can happen. It's not that prevalent. Doesn't happen very often, but I know I've seen some pictures of people that have taken pictures of lenticular clouds. The Ouachitas, they're usually not high enough to produce something like this, but although I'm not going to rule it out, but usually what happens is we have a lot of still waves moving from the Rocky Mountains that can actually still produce even a lenticular cloud here in Arkansas. So that is just a little bit breakdown of the different types of weather when it comes to mountains and how you can get strong winds, of course the Santa Ana winds, but also some really cool features that you may want to watch out for. Next time you're in the mountains, you may get lucky and see a lenticular cloud if you're in Tennessee, North Carolina, or if you're in the Rockies. Be on the lookout for that because it doesn't stick around very long sometimes. Sometimes it's very quick, but it's certainly a shot, a picture that you want to get if you do have that possibility of seeing something like that. Before we close out here with WeatherWise, we're going to go over the Super Tuesday outbreak that happened around 18 years ago and produced a violent EF4 tornado that impacted a lot of counties. Stay tuned. Around 18 years ago, a huge EF4 tornado ripped its way through 7 counties here in the Natural State. It was unusual for the month of February, but the conditions came together just perfectly for a supercell that produced the longest track tornado on record for the Natural State. This thing was on the ground for 122 miles. It started around Centerville in Yell County, made its way through Atkins, Cleveland, Clinton, Mountain View, Zion, and also into Highland into Sharp County. We did lose 13 lives during that event. I've seen some pictures and it was a monster, almost like what happened back in 2014. And going through parts of the mountains that may have enhanced it, just because when we talk about, once again, the mountains, air goes up and over the mountain, that can sometimes enhance tornado formation. So geography plays a part not just in downsloping winds, Santa Ana winds, or also compressional winds. It can also play a huge role in how a tornado interacts with the landscape. The Little Rock tornado actually saw enhancement of its winds when it was going up and over some of the hills around Little Rock, which is pretty much part of the Ouachitas. But February, yeah, we get tornadoes here in the natural state, and the Storm Prediction Center, I just found this, has updated their 30-year climatology when it comes to the probability of a tornado from 1994 all the way through 2024. You see all the colors here, you see the map. So this is for January 1st, and you can find this on the Storm Prediction Center website. But I want to show you what happens as we go throughout the year and how that probability builds up. Here's January, and look what happens. This is getting into February now. It's primarily concentrated in the deep south, into Mississippi and Alabama. But then going from February into March, it starts to really build its way into parts of Arkansas. Certainly the bullseye still over Alabama by the middle part of March. And then look what happens going into the end of March into Mississippi. Your probabilities really start to go up. So the probability now of any type of tornado within 25 miles of a point in those zones, you see the probability into parts of Alabama is about a 2%. Same story for Mississippi. And then April, it starts to shift into Arkansas more, into Oklahoma. And then by April into May, it really starts to build its way into Oklahoma, Kansas, and it's really focused into Kansas and more into Oklahoma once we get into June. So Tornado Alley moves around throughout the year, and that's because the position of the jet stream does change. There's July. So usually here in July, there's nothing going on. It's usually just hot and humid. That's because a ridge of high pressure builds its way across the center part of the country. Your jet stream's usually much farther north, so that's where your wind energy is going to be for storms to develop, and it's going to be focused in the upper plains, the Great Lakes, and also New England. Here's August, and then as the jet stream starts to build its way back down, the severe weather risk starts to increase across Arkansas and the Mid-South and the Deep South into October. And there's November, and then once we get into December, again, it's primarily going to be into Louisiana, Mississippi, and parts of the Deep South. So tornado season really happens here in Arkansas pretty much every month of the year, with the exception of June, July, August, and maybe September. But then it starts really October and goes all the way into May. So we're going into tornado season. Always a good idea to go ahead and make sure you remember those tornado precautions. As we get deeper and deeper into March and April, we'll be here certainly tracking the chance of severe weather, and we'll be able to do it live on the THV 11 Plus streaming app. We can give you hours and hours of uninterrupted coverage and get more in depth than what you can find on any TV platform. So when severe weather strikes, and it will, be sure to stay with us here on THV 11 Plus for the latest and newest information. That's it for Weatherwise. Thanks for tuning in. If you have an idea, you know what to do. Just go ahead and send me an email at nscott@thv11.com, or you can also reach out to my Facebook page. Have a great day. I'll see you soon.